This will be a real, like, I don't think a hard challenge, but a real challenge for you to read this and read this for meaning. Okay, so take a minute. Don't just look at it as a bunch of words and numbers on a page not to be comprehended. Read this. Like, you guys know how, like, I don't know, have you done any stuff with poetry? You know how poetry is, like, really hard to understand? They use, like, these colorful images and metaphors, and you're just kind of like, oh my goodness, they're talking about this, that, and the other thing, and I don't even really understand what they're really talking about. In my personal opinion, this is way easier than poetry, but it certainly would be easy to look at this and just be like, oh my gosh, numbers and words, I don't get it. So take a minute, just try to read it for meaning. Read it as a story. Don't worry about the math right now. Just read it as a story and decide, should I draw a picture of this situation? So take a minute. Go for it. Avery, can you describe in your own words what is happening in this question?
Two cars are going two different directions, I guess, but they're going to be at the same place at different speeds.
Did you guys hear that?
Yeah.
Say it one more time, Avery.
Okay, two different cars are going two different speeds, and they're going to meet in the same place.
Can you describe their directions relative to each other? Are they driving away from each other or towards each other?
Towards each other.
Towards each other. Can you guys picture the same thing? Got two cars, different speeds, different cars, heading towards each other, and Avery said they're going to meet, right? Awesome. Okay, you can open your eyes. That was a pretty good interpretation, wasn't it? I'm hoping that you were thinking something like that. So, got two different cars starting far apart, and they're driving towards each other. And if they're driving towards each other, at some point they're going to meet, right? Meet somewhere in the middle. Okay, that's a really good description. Let's take a minute and decide, do we need to draw a picture of this? Would that be helpful, or would it just be kind of useless? Helpful, yes, definitely helpful. So what I'm going to do is I'm going to attempt to just draw this out, just map this out, not with any kind of a fancy map or anything like that. I'm going to say that over here on the left, we're going to say that that is Rockford, some city, I guess. And on the other side over here, that is going to be, I don't know, any guesses on how to say that? Wausau? Something like that. So you got these two cities. They are far apart. 157.5 miles to be exact, like if you read the question. They're far apart. And you got these two cars. It says a car leaving Rockford, traveling at 55 miles per hour. Another car leaves Wausau, traveling towards Rockford. They're traveling towards each other at a rate of 50 miles per hour. How long will it take them to meet if the cities are 157.5 miles apart? So I think I would illustrate the picture something like this. I'm going to say that I've got this car. Oops, let's try this again. I got a car going from Wausau towards Rockford, and then I've got the car going from Rockford towards Wausau. And they're going to meet somewhere there in the middle, aren't they? Yeah? Okay. So I want to label my picture a little bit. I want to label my purple arrow and my green arrow. How do you think I could label my purple arrow? Like, what would make sense? Yes, Ashlyn.
You could say 55.
And what is 55 miles per hour? Is that like a distance, a rate? It's a rate, right? Would it be? Now, I agree with you on the 55, but like when I look at my picture really is not about speed, is it? Isn't it about like location of the cities? So while we could put a 55 right there, and I get why you would do that, let's think of a little different way of labeling. That make sense? Because the picture is not really about speed right now. It's about position. Like, where are the cities and where are the cars? So what do you think? What could I label? This is an unknown, right? We don't know. Like, we don't know how long the purple arrow is. We don't know how long the green arrow is. Go ahead.
Well, I guess you could maybe divide 157.5 by 2.
You would think so, and in certain cases that would work. But those cars are not going the same speed, are they? If they were going the same speed, then that's exactly what you'd do, and then, it'd be over with pretty quick, right? But unfortunately, they're not going the same speed, so we can't do that. Alec?
Could you divide by the difference of the speeds?
Yeah, I don't think that's going to work either. You guys are like really seeking to get a number here. I'll say what I said again. We don't know how long the purple arrow is.
Then X.
And we don't know how long the green arrow is either, do we?
Why? X and Y.
Can we be a little more descriptive than just X and Y?
But those as the times.
R and W.
Okay, yeah,
Put that
but
next to the
R stands for Rockford. I mean, I know where Rockford is. It's not the length of an arrow, it's a city.
Okay, P and G.
What did that stand for?
Are you serious?
No. Think about the situation. Hey, listen, I'm pushing you to like understand concept and context, not just colors and numbers, right?
Wouldn't it equal Y? Like it would be
What does Y mean though?
the time and then X.
Oh, and it's not a time. No, I'm sorry.
Oh.
T,
T, R, and T.
Which of those should we use?
R and T. D and R. D and T. Just R and D.
You're just guessing now. I think I would go with actually what Emily just said. Say it again. Yes. So I'm going to say this. I'm going to say purple is distance of car 1. There are 2 different cars, right? Wouldn't that purple arrow represent the distance of one of them? And I would say the green arrow would represent the distance of the other one, so I'm going to call that D2. Does that make sense? I think those arrows really have to represent distances. Okay? So now, finally, you guys did some really good thinking and some good work right there. Finally, we need to come up with an equation that's going to help us express this. There's one more thing on the picture maybe I ought to label. How far is it between the cities?
157.5.
So I'm going to say from here all the way over to here is 157.5. That whole distance between the cities is that far. So with I've got like the distance 1, I've got the distance 2, I've got the 157.5. Can anyone tell us a true equation that has to do with this stuff? Like how could I relate distance 1, distance 2, and the 157.5? Like with an equation, remember an equation must have equal sign. What could I say? Connor.
Distance 1 plus distance 2 equals 157.5.
Okay, let's write that down real quick. So he says distance 1 plus distance 2 equals 157.5. What do you guys think of as far as the truthness of that? Is that true?
Yes.
Everybody said yes. Anybody say no? The purple distance plus the green distance equals the total distance between the cities. Does that ring true for everybody? Yeah, that's totally true, isn't it? So remember, when you write an equation, it has to have to do with the stuff we care about, like the distances and everything. But it also has to be true. So I think a picture is extremely helpful here. You can say, hey, look, the towns are this far apart, so if you add up the 2 distances, you've got to come up with 157.5. That makes sense? Okay. Is this pushing the envelope for you a little bit? I hope that it is. This is good. Now our final little work with setup before we just turn to some algebra is going to be right here. I've got D1 and D2. That's good, but it's not as helpful as it could be. I told you to try to think about this and remember this for today, and Grace started to touch on this a little bit ago. What is distance equal to in these sorts of situations?
Rate times time.
Rate times time. So what I'm going to do now is I'm going to expand what D1 really is. Wouldn't it be fair to say that D1 is rate 1 times time 1?
Yeah.
And D2 would be rate 2 times time 2. So all I'm doing is I'm just saying essentially that distance is equal to rate times time. I've just expanded what D is. D is equal to RT. And now finally we can start plugging stuff in. Before we do, let me know if you have any questions on that.
I do. I'm confused.
Okay, so I'll write this off to the side and I'll erase it. this is the equation for distance, rate, and time.
Yeah, I get that.
Distance is equal to rate times time. So what I did is I replaced distance with rate times time.
Why did you put the ones?
So the ones have to do with car one, right? There's two different cars.
Oh,
If-
so if it was labeled like something other than D, you wouldn't have to put them there? So it's since like they're both labeled D, if one of them was labeled something.
Yeah, exactly. Yeah, so they're both D's, and so I got to distinguish between the two of them. And I do that just by putting the little subscript one. So it's like distance of car one,
But
or
like, what if one was like an A and one was a B? Then you wouldn't have to do the ones and twos.
no,
Okay.
no. But then when you went to RT, you'd have to distinguish between with the two different R's and potentially the two different T's. Right.
Yeah.
So I need to be able to tell them apart. So you can use little subscripts for that. That's what I tend to do. Anyway, so let's fill in some stuff. We do know some stuff here. You go back up here. Can anybody identify the rate of car one? What is it, Emily? It's right there. Yeah, 55. So the rate of car one is 55. So I'm going to replace R1 with 55. I still got that T1. And then how about the rate of car 2? 50 miles per hour. It's highlighted right there. So I'm going to put 50. Oops.
Was that 55?
The first one's 55. Second one's 50. I got one last thing to say before we solve this. Does it say anything about time in our description? It does say a little bit of something.
They left at the same time.
They left at the same time. And we don't know if that was 10 a.m. or 1 p.m. or whenever. We don't really care. We know that they left at the same time. So as you guys know, in this D equals RT thing, the T does not stand for the time of day. Right? Really, I mean, whether you're driving at 11 p.m. or 9 a.m., you're still going the same speed, right? So T doesn't stand for time of day. It stands for the time that you've been driving, right? So if these two cars started at the same time and then met in the middle, what could we say about T1 and T2?
It's infinite.
They're what?
The same.
They're the same, right? If they started at the same time and then they meet in the middle and stop, I think that the time that they drove would be the same. So I think I'm going to do this, say, you know what, T1 and T2 are the same thing. So why couldn't I just drop the subscripts on those and just say 55T plus 50T is equal to 157.5. After all that work, we finally arrived at an equation that I think we're all pretty good at solving, right? I think we just saw some demonstration of that. So if you would, take a minute, remember to simplify first. And I'll let you guys finish this one off. You've put in some good effort to get to this point. Let's see if you can finish it off, and we'll get the correct answer. Notice the question itself did say, how long will it take them to meet? So how long will it take them to meet? That's a time question. So we're about to find a time, so I think we're in pretty good shape. So I'll let you solve that. Take just a couple minutes to do that. Let me finish this real quick. We finished, before I accidentally erased that, we finished with 55T plus 50T is equal to 157.5, right? So what do you do on the left side?
Combine.
You combine, yep, combine like terms. So I'm going to come back up here. So you end up with 105T is equal to 157.5. And then how do you get the T all the way by itself? Dividing both sides by 105. And Jake, I don't think that number you came up with is right. What'd you guys come up with?
1.5.
1.5. Yeah, that sounds about right. So 1.5 hours. And notice what it asked. It said, how long will it take? Like I mentioned before, that's a time question, and 1.5 hours is a time. So that is actually exactly how long it would take for them to meet in the middle.
How do you know they met in the middle though?
Well, so the reason, so I am sorry that I erased it. We know that they met in the middle based on our setup. Let me wipe this clean. What we set up here, we set up Rockford over here, and we set Wausau over here. Now, I think what you just said a second ago, Connor, you said, how do we know they met in the middle? I'm pretty sure that they did not meet in the exact middle. In fact, I'm absolutely certain that they did not meet right in the middle. I would say that the car traveling from Rockford went a little bit further than the car traveling from Wausau. So when I say in the middle, I don't mean like the geometric middle. I'm just saying somewhere in between.
Okay.
Yeah. Okay, other questions? Yes, sir. Of course. Of course you can. Of course you can. You're going to miss out on the start of this next question. I hope it goes quickly for you. Yeah.
I don't really get that. So I know we got this equation, but like I didn't get it past that point.
Okay, I will help you with that here in just a second.
Mr. Anderson.
I'll sit with you.
I did something different than yours, but I got like the exact.
I'll be happy to sit with you. Check that out. Okay, ladies, gentlemen, I want you guys to take a look at number 2. This is similar situation, but implied about where these two cars, the minivan and the car, where did they start? At the same spot. I agree. So I'm going to say something like this. I'm going to put M for minivan, and I'm going to put C for car. And, oh, come on. So the minivan takes off, right? And it gets a little bit of a head start. And then it says, how long would it take the car to overtake or catch the minivan, right? So did you guys draw a picture, maybe something like this, where the car's distance eventually equals that of the minivan? No. Shouldn't it, though? Think about it. If they start in the same spot and the minivan takes off, isn't the minivan going to get ahead? No. But if the car is really traveling faster, won't the car eventually catch up to the minivan? No. I think we go with this picture here. We want to be really flexible and read for meaning. Like that first one we did, didn't the picture look pretty different? We had two cars traveling towards each other. This one, they're not traveling towards each other at all. They're actually going the same direction. It's just that one had a head start. But in the end, won't they start at the same spot and end at the same spot? Yeah. Okay. So then what could I say about their distances? Remember, the purple and the blue have to do with the distances. What could I say about the distance of the minivan and the distance of the car? They're the same, right? They started in the same place. They ended in the same place. This was not true of the previous example, was it? They did not go the same distance, but in this example, they are. So if they are the same distance, what equation would you use? What equation could you write?
D equals rate times.
Well, yeah, distance equals rate times time, but for this situation with the minivan and the car, what equation is true about their distances? They're the same. And in math, what is the same?
Equal.
So what exactly should we write?
Right. D equals.
Say again? So you're all talking so quiet. Say it again, Avery.
I just said something plus something. It wasn't anything. It was
Okay. I don't think we need to add anything right now. I don't know. Maybe this is obvious enough that you're just not saying it. I would say something like this. Distance of minivan equals distance of car. Does that make sense? Hello. I asked you a question and you all just sort of turned your head and looked away. I need you to say, yes, I do, or no, I don't.
Why is it because
Distance of minivan. They're two different cars, or two different vehicles traveling. So I want distance of minivan, distance of car. They have to be the same distance because they started in the same spot and they ended in the same spot. That still makes sense?
Yes.
Okay. I got 5 minutes left, right? We go till 10:25?
Yeah.
I think so. Okay. So now, distance in general equals what times what?
Rate times time.
Rate times time. Okay, so I'm going to put rate of minivan times time of minivan is equal to rate of car times time of car. So distance of minivan equals distance of car, and then we're always going to say, well, distance equals rate times time. So we'll always expand it out into these two expressions. So we do know half of this already, don't we?
Yes.
What do we know? We know the rate. So the car traveling at 60 and the minivan traveling at 50. So I'm going to replace rate of minivan with 50 and rate of car with 60. Does that make sense? Just pulling that right out of the question and dropping it in the appropriate spot.
Wait,
Now-
why did you do 50 TM? Shouldn't it be 50 MT?
So
Oh, never mind.
TM stands for time of minivan. It's not a multiplication, it's just a little subscript. Okay. So our final thing is this, the times. In the previous question, the one we talked about with Rockford and Wausau or whatever, weren't the times the same? In this case, the times not the same. Can anyone describe, based on the wording, you're going to need to read this for meaning. I'm not going to hold your hand through this because you need to know like some of these steps. You need to figure some of these steps out for yourself. How are their times different? Paige, go ahead.
By 30 minutes.
By 30 minutes. I think we should probably use hours here
Okay.
because it's in miles per hour.
5 hours.
Half an hour, right? Yeah, okay, so their times differ by a half hour. Which one has the longer time?
Wait, which one's
It says right here, the minivan had a half hour head start. That means the minivan started a half hour before the car, but they stopped at the same time, right? Because the car eventually caught the minivan. So I would say that the minivan had the longer time. Does that make sense? Makes sense. Okay, so what we need to do here is say, we could replace TM, say something like this. This would be T plus 1/2. And over here, time of car would just be T. So you see how that would essentially set us up with the minivan having the half hour longer time. Car is T, minivan is T plus a half hour.
Oh,
Okay. All right, so then we solve this, and here's some beautiful stuff here for us to solve with. We need to simplify first, and what do you see happening on the left side?
Distributed.
Distributive, yes, it's right there, distributive property. So we're going to put 50t plus 25 is equal to 60t. And now I need to continue to simplify because I've got a t on the left side and a t on the right side. So how do I get those together?
Kill the little one.
That's right. So we need to do what
Subtract
specifically?
50 from
There you go.
both sides.
Got it. So we're going to move that 50t over by subtraction from both sides. So that would give me 25 is equal to 10t. Final step.
Divide by 10.
Dividing by 10, I get 2.5 hours equals t. So apparently it's going to take the car 2.5 hours to catch up. Okay.